All right, page 2 of the 2.2 notes. Example 4, here's f of x, here's g of x, and again we want to find where these things are equal. We want to solve algebraically and also look at the graph of these two things. So like the first page, let's solve algebraically first. All right, so we've got 2 times the absolute value of x plus 5 minus 1 equals negative 5. Okay, well, like we showed on the last page, we want to get the absolute value part by itself first. So let's start with adding 1 to both sides. And that gives us 2 times the absolute value of x plus 5 equals negative 4. And then when we divide both sides by positive 2, we get the absolute value of x plus 5 equals negative 2. Okay, so now that I got the absolute value part, should we set up our two equations? Well, no, because again, take a look at this. Don't worry about what's in there, but I got the absolute value of something. When does the absolute value of something equal negative 2? Well, it can't, right? Because no matter what's in here, the absolute value bar is just going to make it positive. So then what's that mean? Well, this one has no solution. Okay, because again, we can't take the absolute value of something and have it come out a negative number. Okay, now could I set up two equations? X plus 5 equals negative 2 and x plus 5 equals 2 and get a couple answers? Yeah, but they'd be bogus answers. They wouldn't work. So once you get the absolute value part by itself, you got to stop and think for a second and evaluate this thing. Can this happen? If not, great, no solution, we're done. Okay, now what does that look like on the graph? Well, if I graph this function, my vertex is going to be at negative 5, comma negative 1. That's going to be right there with a slope of 2, so up 2 over 1, up 2 over 1 the other way. Those 3 points are enough. I can draw my V. It's about like that. And then what would g of x look like? Well, it's the line y equals negative 5, so we're going to go down 5. Draw a horizontal line. And then there's g of x. Well, where do my two functions intercept? Oh, nowhere, they don't. So then that's why there's no solution. Okay, these two functions are never equal because they graphically don't intercept, which is why we got no solution when we solved algebraically. So that will happen occasionally. Keep an eye out for that. Okay, and then at the bottom we have some more practice. We got 5 more examples, so let's get through these. Okay, so they want us to solve the absolute value equations and graph the solutions on a number line. If there is no solution, write none and explain why. All right, so the first one, we've already got the absolute value part by itself. It doesn't matter that it's on the right side. We can switch it around if we want to, but since the absolute value part is by itself, we can set up our two equations. I'm going to zoom in a little bit. All right, so then I want to know, when does this stuff equal 19 and when does this stuff equal negative 19? Okay, so then 5x minus 1 equals 19 is going to give us an answer. 5x minus 1 equals negative 19 is going to give us our second answer. Okay, we add 1 to both sides. I get 5x equals 20. Divide both sides by 5. And we get x equals 4. Okay, so that's one answer. Do the same algebraic steps on the other side. Add 1. And we get 5x equals negative 18. And then divide by 5. And we get x equals negative 18 over 5. And just leave it as a fraction. Okay, don't worry about decimals or anything. Just leave it as a fraction. All right, so then those are our two answers. And then we want to graph those on a number line. Okay, so a number line is just that horizontal line that has a bunch of numbers on it. Okay, do I have to put 0 in the middle? Well, no, not really. What 2 points have to be on there? Well, 4 and negative 18 over 5, because those are my answers. So I'm going to say, okay, over here somewhere, this is where x equals 4. And then somewhere to the left of that, since it's a negative number, is my other answer, negative 18 over 5. Okay, had to write real small there. Okay, but yeah, those are the only two numbers you need on there. If you want to put 0 somewhere in between those, hey, that's fine too, but it's not required. Okay, 4 more to go. All right, next one, example 6. Now let's see, we want to get the absolute value part by itself. So let's start by dividing both sides by 2, which gives us the absolute value of 4x plus 7 equals, well, still 0. Okay. Now let's think about this for a second. Ignore what's in there, that doesn't matter. The absolute value of what number equals 0? Okay, 0, what else? Nothing. So this is that special case they were talking about on the first page. When you have the absolute value of something equals 0, you're only going to get one answer. Okay, so then we only need to set up one equation. I just want to know, when does this stuff equal 0? Okay, so then to solve that, we want to subtract 7, which gives us 4x equals negative 7, and then divide both sides by 4. And we get x equals negative 7 over 4. Okay, and then we want to put that on a number line. We'll squeeze it in over here. Here's my number line. And then what's the only point that I really need on that number line? Well, negative 7 over 4. Now, since it's a negative number, if you do want to put 0 there, just to say, okay, 0's here, this negative number is somewhere to the left of it, that's fine, but again, you don't have to. Okay, so there is example number 6. Example number 7. Here, 6 minus the absolute value of something equals 16. So we want to get the absolute value part by itself. Let's start by subtracting 6 from both sides. And then that gives me negative the absolute value of 2x plus 3 equals 10. And then next, the negative there, if it makes you feel better, you can put negative 1. How do I get rid of the negative 1? Well, I can multiply by negative 1 or divide by negative 1. Doesn't really matter. It achieves the same goal. So we'll go ahead and multiply both sides by negative 1. And then that gives me the absolute value of 2x plus 3 equals negative 10. So then do I set up my two equations and do all that stuff? Well, no, because again, let's look at this thing. The absolute value of what number equals negative 10? Well, nothing, right? So my answer is no solution. Okay, so even though it didn't start off as a negative number here, once we got the absolute value part by itself, we have the absolute value of something equals a negative number. Well, that can't happen. Okay, 2 more to go. Example number 8. Again, we want to get the absolute value part by itself, so let's just jump right into it and add 4 to both sides. And we get 1/3 times the absolute value of 2x minus 5 equals 11. And then next, to get rid of the 1/3, I want to multiply both sides by its reciprocal, which is 3 over 1, which is just 3. So then we get the absolute value of 2x minus 5 equals 33. Okay, so then the absolute value of what number equals 33? Well, 33 and negative 33. So yeah, this one does work. I just want to see, when does this stuff, 2x minus 5, equal 33, and when does 2x minus 5 equal negative 33? Okay. To solve these, we're going to do the same algebraic steps on both sides. We're going to add 5 to both sides first in both equations. We'll go ahead and solve these at the same time, which gives us 2x equals 38, and 2x equals negative 28. Okay, and then last step, divide both sides by 2 in both equations. And then we get x equals 19 and x equals negative 14. Okay, so then those are my two answers. And again, if you're not sure, plug them in and check. But yeah, those work. Okay, and then the last thing, let's graph these on a number line. And again, the only 2 points that we really need on there are 19, which is going to be somewhere on the right of negative 14. If you want to put 0 somewhere in the middle, maybe a tiny bit closer to the negative 14, then yeah, you can do that, but you don't really have to, but you can if you want to. All right, and then the last one, almost done here. Last one, 5 minus 2 times the absolute value of x equals negative 25. So since it equals a negative number, is it no solution? Maybe, but let's get this thing by itself first. We'll start by adding 5 to both sides. I'm sorry, subtracting 5. Subtracting 5. So we get negative 2 times the absolute value of x equals negative 30. And then divide both sides by negative 2. And we get the absolute value of x equals positive 15. So it did become positive, so yeah, we can solve this one. And this one is pretty nice. There's not really any algebra to do. The absolute value of what number equals 15? Well, positive 15 and negative 15. So then that's our last answer, and that wraps up the notes.